Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by Gauteng Department of Education in collaboration with Saipono Discovery Center and is broadcast by Pakama Research and Development. We have our WhatsApp number is 060-667-5044. For all your questions, just ask your questions. We'll be able to respond during the lesson. So we must interact with one another via that WhatsApp. Thank you. Our topic for today is fiscal properties. So we are doing fiscal properties today. We are hoping that you will understand. This is question 3. This is one of the questions that learners were not doing well in the previous papers. So we're looking forward to ensure that with your cohort, you will do very well in this topic. So we thank you very much. We're looking forward to a fruitful day. Remember, in grade 12, we are saying we have 47 marks for organic molecules. So this 47 marks is 62% of our paper. So we have 47 marks, 62%. Remember, a paper 2 is a 75 marks a paper. So out of the 75, 47 comes from organic molecules, and then 28 will come from chemical change. The focus of today is metal materials with specific focus on fiscal properties. So I'm looking forward to you enjoying this. Remember, we're saying paper 2, you write for 1.5 hours, and then we're saying we have those weightings according to the levels, and that is the structure of the paper. I wanted you to understand how this is going to contribute to your marks. As indicated, we're doing unit 2 today. Unit 2 is that one, which is fiscal properties. So that is the focus for today. Now, without any wasting of time, we'll go straight to it. Now, these are the objectives. The objectives that we are having are these. These are fiscal properties. So when you talk about fiscal properties, we are referring here to boiling point, melting point, vapor pressure, and viscosity. So for tech science, there are 4 fiscal conditions or properties that we look at. So those are the 4: boiling point, melting point, vapor pressure, and viscosity. In terms of order, I always want to arrange them from melting point, boiling point, vapor pressure, and then viscosity. So in that order, that is how our lesson will be, because our main focus is those 4. Remember, when you are having a solid, it will melt, then it will become a liquid. When it's in liquid form, if you continue to heat it, it will change to a gaseous form. So that's when we'll reach our boiling point. We're going to talk about that. Then immediately when there is gas is formed, there will be vapor that is produced. Then we'll be able to talk about vapor pressure. And lastly, we'll talk about viscosity. So that is the focus of this lesson, is on those 4 properties that we're going to look at in terms of organic molecules. Now, bullet number 2 from the exam guideline says, discuss relationships in fiscal properties of alkanes, alkenes, alkynes, haloalkanes, aldehyde, ketones, alcohols, carboxylic acid, and esters. Remember, I'm saying to you, we have 9 homologous series that we're going to focus on. This one, I want to always ensure that you don't forget. We are doing, for technical science, 9 homologous series. Of those 9, we are saying AAA, which is our hydrocarbon, our alkanes, alkenes, and alkynes. You will see why I'm grouping them together, because alkanes, alkenes, and alkynes will have the same intermolecular force. So it's important that you look at them as hydrocarbons. They have the same intermolecular force. So we're going to identify that intermolecular force for AAA, which is our alkanes, alkenes, and alkynes. Then we'll go to Hague. I think you like Hague. So the Hague is for haloalkanes, aldehyde, ketones, and esters. So for those 4 as well, they have their specific intermolecular force that we're going to focus on during this lesson. So what is common for all the hydrocarbons, AAA, the first 3, they have the same intermolecular force. Hague, which is the other 4 homologous series, they have the same intermolecular forces. So we're going to look at that to say, what are the intermolecular forces that we find in alkanes, alkenes, and alkynes, which are hydrocarbons? And I'm saying they will have the same intermolecular force. What are the intermolecular force that we'll get from haloalkanes, aldehyde, ketones, and esters? So we're looking at that. Lastly, we'll look at the last 2 now, which is our alcohols and carboxylic acid. So those 2 as well, they have the same types of intermolecular forces. I hope that is clear. So we're going to look at the melting point, boiling point, vapor pressure, viscosity of all these 9 different homologous series. Now we're going to compare physical properties of different homologous series as I indicated, which is bullet number 3 from the exam guideline. The fourth bullet, it says for a given example from the above functional group. Remember, we're having this 9 homologous series, which means we have 9 different functional groups that we talk to. So we're saying for all these given functional group, you're going to explain the relationship between physical properties and 4 things that we're looking at there. You can see the first thing, we're going to look at strength of intermolecular force, which can be hydrogen bonds, dipole, or induced dipole forces, which is our London forces. Then we're going to look at the type of functions, type of functional group, and then chain length and branch. You can see I've tried to simplify it for you here. I wrote if chain mob. You can see there I've written if chain mob. So I'm simply saying to yourself that don't forget, we're looking at the physical properties. It can be melting point, for example. So when you look at the melting point, we'll look at the intermolecular force. The I there is for intermolecular force. Number 2, we'll look at the functional group. Number 3, we'll look at the chain length. How long is the chain? How is the chain going to influence the melting point, boiling point, vapor pressure, and viscosity? So we are going to look at the molecular mass as well to say how does a molecular mass influence the melting point, boiling point, vapor pressure, and viscosity. Lastly, it will be the branch to say how does, if the number of branches increases, how does that influence our melting point, boiling point, vapor pressure, and viscosity. So that is a short and long of our lesson. So we'll do that, then we'll be able to move and do activities to say in the exam, how do I answer questions? So that is very much important for you to understand. But don't forget, this time we're moving with if chain mob. We're saying the I is for intermolecular force, the F is for the type of functional group, the chain length, the molecular mass, and the branch. So we're going to look at those. Don't forget the B is for branch to say if we have many branches, how is that going to influence the melting point, boiling point, vapor pressure, and viscosity. So that is my introduction, and these are the objectives, which means I'm saying to you at the end of this lesson, you must go back to the exam guideline and check that did we address all the bullets that needs to be addressed. Do you understand everything that you're expected to know before you go and sit for your exam? Remember, prelims are coming, so we're looking forward towards that. Now, the first thing that we have to know is that, remember, we're talking about physical change. Physical change, we're saying, is observed with senses. During physical change, the original substance is produced. For example, I took water here as an example, H2O. I'm going to use that as your example to say if you have water in a solid form, you can see the structure is fixed. They are joined together. You can see the bonds between the water molecules there. The water being the blue stuff there that you see, those blue circles, they're indicating your water in solid forms. The structure, the intermolecular force are the strongest, which means the structure is joined together with strong. I think you have seen it with ice. When you take out your ice, is melted. Sometimes you have to heat on the ground so that it can break, because you are unable to use it in its form because the intermolecular force are very strong. Now the question is, how do we convert from solid? Remember, we're saying this is physical change. So we're going to change from solid to liquid. What do? You're going to increase the temperature. You're going to increase energy. In this case, we don't talk about temperature. We talk about energy, because you know temperature is your average kinetic energy that we are referring to. So we are saying to you now, for you to move from solid to liquid, you must increase energy. Why do you need energy? You want to overcome the intermolecular force. So the first thing that I'm emphasizing, I'm saying when you are having a water molecule like that, that water molecule is joined to another water molecule, which is joined to another water molecule. So all this, the bonds that you are seeing there with the brownish color there, is the bond that is joining one water molecule to another water molecule. That's why we are referring to the force between them as intermolecular force. I want to explain that. I think I'll write it at the top. The force, we are calling it intermolecular force. intermolecular force. Is the force that is holding on the water molecules together. Now, for you to change from solid, which is ice, to water now, which is liquid, you need energy. You need energy. Why do you need energy? You need energy to overcome the intermolecular force. So these forces that are joining the water molecules here, as indicated, you need to overcome them. You don't break the intermolecular force here. You are overcoming them. So when you overcome something, it means it remains. So the intermolecular force is not going anywhere, but what we are doing, we are overcoming it so that it's no longer as strong as it was. Then the water will now change. You will see what we refer to as physical change. The solid now will become liquid. Remember, as we are moving from solid, we are going towards liquid. So the solid will be forming the liquid as we increase the energy. So there are two things that I want you to look at. The first thing, you have to realize that the structures themselves, the intermolecular, the molecules themselves, they have what we refer to as intermolecular force. In this case, I'm using the water as an example. However, we're going to apply this in organic molecules to say organic molecules are joined together by intermolecular force. The intermolecular force simply means that water is a molecule. So when you see water, you see a molecule. And then between them, there is a force between them. So that's why we're saying inter. Inter means between. So we're saying this is the force that is there between the molecules. Hence, we refer to it as inter, which means between what? Molecules. So what do we have? We have a force. So we're saying for you to change from solid to liquid, you have to overcome the intermolecular force. What do you use to overcome the intermolecular force? You're going to need energy. That's why here we indicated in this slide to say you have to add energy. Immediately when you add energy, solid will now start to become liquid. Solid will become liquid. Then if you are continuing now to increase energy, what will happen is that the solid now, more of the solid is becoming liquid. You have seen that with ice. Most of the time, it now starts to melt. Then it becomes water, then in a liquid form. Remember, water remains water. It doesn't change. H2O is H2O, whether in solid form, whether in liquid form, or in gaseous form. So you know that we still have water, but it's in different phase. So what is changing is the phase. It's changing from solid to liquid. Now, we have, as I indicated, we're going to do 4 physical properties here. So we have to know how to define them. The 4 properties that we are doing, you must know their definition. So we're saying the first one, obviously we're having a solid becoming a liquid. So we must define what is called melting point. What you have to understand, learners, is that when solid changes to liquid, that is not melting point. That is melting. So melting is a change from one phase to another. However, when I say melting point, I'm referring to a specific temperature. So you must be able to know that immediately when you say melting with a point is saying this is a what? It's a temperature. So melting point is a temperature. What happens at that temperature is a temperature at which the solid phase, remember we're having solid, the solid phase and the liquid phase are at equilibrium. What do you mean, say? I'm saying to you, when the solid starts to become the liquid will, some of the liquid will go back and form solid. So when the two are at equilibrium, we say melting, that is the melting point. So when we define melting point, we are simply saying the solid phase and the liquid phase are at equilibrium. So know the definition. I just did the first definition for the day to say our first definition was saying melting point is a temperature. It's not a point, it's a temperature at which the solid phase and the liquid phase are at equilibrium. I hope I explained that nicely. You won't forget it. So remember all the time, when we are saying melting, you think about solid becoming liquid. Then melting point is a temperature at which the solid phase is at equilibrium with the liquid phase. So understand that, then you will get your 2 marks in the exam. You will see, because we will be doing past exam papers, you will see you will be asked to define melting point. So you will always refer to it as the temperature at which the solid phase and the liquid phase are at equilibrium. I hope I've emphasized it and you know it now for life that, oh, we have the solid becoming the liquid. Then when you increase temperature, when you increase energy, you will overcome the intermolecular forces. Then the solid will now change to liquid. When the solid phase and the liquid phase are at equilibrium at that temperature, when the solid phase and the liquid phase are at equilibrium, we'll refer to it as the melting point. So I think you know by now, you know the definition of a melting point. The second definition that you are supposed to know, remember, our water now, because we've passed the melting point, our solid now is in liquid form. So if you continue to add energy, so energy is always required. Remember what I said about energy. The energy required is to overcome the intermolecular force. All the time, you must always put that statement like that to say the energy is to overcome intermolecular force. Don't forget what we need energy for. So if you have a liquid, water in liquid form, the same water that you are using at home in liquid form, we are saying when you increase temperature, when you continue to increase the energy, what is going to happen? You are going to overcome the intermolecular force. Then the water will now change phase from liquid to gas. So when the water starts to change from liquid to gas, we say the water is vaporizing. There is vapor that is being formed. Now we define that as the boiling point. So what is the boiling point? We're saying the boiling point still is not a point. Remember, I emphasized that melting point is not a point, it's a temperature. It's happening at that temperature because it's melting. The solid phase and the liquid phase are at equilibrium. Now we're going to the second definition, which is the boiling point. We're saying boiling point is a temperature as well. So it's a temperature. What is happening at this temperature is the temperature at which the vapor pressure, which is inside the liquid, is equals to the atmospheric pressure. VP equals to AP for you to remember, but you can't write that in the exam. So always you start by saying this one is a temperature. What is happening at this temperature called boiling point? The vapor pressure. Remember, I'm saying inside the container, there will be vapor pressure. That is because you are heating the water, you are increasing the energy. You have seen when you are putting a pot, maybe you want to cook something, when you boil the water, the vapor starts to occur inside the water. You will have the vapor produced in the water. So that's the one we're referring to. Now you start to have what we call referred to as the vapor pressure. So we're saying at the boiling point, when water boils, it means the temperature, the vapor pressure, the pressure inside of the vapor, which is vapor pressure, will be equal to the vapor outside, which is the atmospheric pressure. Remember, we are saying here above sea level, our atmospheric pressure is 101.3 kilopascals. So it means when the pressure inside the vapor pressure, when it becomes 101.3 kilopascals or 1 atm, which is another unit you can use for pressure, 1 atm, when it reaches 1 atm, we know that the vapor pressure inside the container is equals to the atmospheric pressure, because atmospheric pressure is 101.3 kilopascals. You see the beauty of science? It means when you're boiling water, you know what you are doing. You are simply converting you are moving the vapor pressure, increasing the vapor pressure in such a way that is equals to the atmospheric pressure. Then immediately when the water boils, you know that the vapor pressure is equals to atmospheric pressure. I indicated that atmospheric pressure is 101.3 kilopascals or 1 atm. So you have to all the time. With melting point is equilibrium. With boiling point is equal sign. They are equal. So what am I saying? Melting point, we are saying, is the temperature at which the solid phase and the liquid phase are at equilibrium. And then the boiling point, the vapor pressure is equal to the atmospheric pressure. So I don't want you to cram the definitions. I want you to have an understanding what is happening. Remember, I said immediately when the vapor is being formed, we are having the gas that is being produced now in the container. So now we must be able to define for ourselves what is this vapor pressure. So we must be able to define what is vapor pressure. So I want to get a space so I can define for you vapor pressure. Now vapor pressure in this case, we are saying when you look at the name itself, you just start with the pressure. So vapor pressure is the pressure exerted by what? By vapor. So it's the pressure exerted by vapor. So the first part, you must get it correctly. Is the pressure exerted by vapor at equilibrium. Oh, we have another equilibrium now. Pressure exerted by vapor at equilibrium with its liquid. For melting point, it was a solid at equilibrium with its liquid. Solid at temperature at which the solid phase is at equilibrium with its liquid. But with the vapor pressure, we're saying is the pressure exerted by vapor at equilibrium with its liquid. Look at the goodness of this. But we are saying in a closed system. Remember, learners, these particles, they are now, the water is boiling. So if the water is boiling, obviously, if you don't close the system, the water will leave your container, and then you won't be able to reach your equilibrium. That's why it's important that when you define vapor pressure, you must say in a closed system. But when we define melting point, we just said the solid phase and the liquid phase are at equilibrium. Why? Because when the water is moving from solid to liquid, there is very little, if there is any, of water that is vaporizing and that we can lose because of that. That's why we don't mention that in a closed system. But in real sense, it's a closed system. Remember, this one is isolated from, we said a closed system is isolated from its surrounding. So still, it won't be interacting with surrounding that much that it will. We have to mention for melting point, that melting point in a closed system. But in real sense, is still isolated from the surrounding, because the water molecule not much water molecules will leave the container. But for vapor pressure, you have to explain that it must be in a closed system because the water is boiling, and if you don't close the pot, the water will migrate out of the pot in a gaseous form. So that's why it's important. Vapor pressure, I'm emphasizing, always mention that in a closed system. So we have two definitions that have equilibrium. Is the definition of melting point and the definition of vapor pressure. And I'm emphasizing to you to say the difference for melting point, you said is the temperature at which the solid phase and the liquid phase are at equilibrium. However, for vapor pressure, you said is the pressure exerted by vapor at equilibrium with its liquid in a closed system. I said we close the system because we don't want no molecule of water must leave that pot. We must close the system so that we are able to reach our equilibrium. I hope I was able to explain that. So these are the definitions that you're expecting in question 3. Our last definition is that of viscosity, which is the property of the fluid to oppose relative motion between two adjacent layers. So when you have two adjacent layers, so that ability to be able to oppose relative motion between two adjacent layers, we refer to it as viscosity. I think we have a question on viscosity that we're going to do today, and I hope you will be able to enjoy our questions when we do them. Now, it's very much important that we lay a good foundation so that when we go to do questions, we understand how to answer questions and how these forces are behaving. Now, let's look at, remember we said we have 9 homologous series. So I said AAA, which is your alkanes, alkenes, and alkynes. The hydrocarbons. The hydrocarbons, all of them, those hydrocarbons, they have forces. Their forces are called London forces. So we know AAA, the first 3 hydrocarbons, they have the same intermolecular force. We refer to it as we refer to it as London force. So you have to know the forces for all of this. Hake, let's go to Hake, which is your haloalkanes, aldehyde, ketones, and esters. They have London forces and dipole forces. So you can see, if I was to ask you which one, in terms of strength, which one is stronger between the hydrocarbons, the hydrocarbons and Hake, these other 4 homologous series, which one have stronger intermolecular force? Obviously, you're going to choose Hake, because all these 4, they have 2 types of forces, which is the London forces and the dipole. While when you look at hydrocarbons, they have only one forces, which is the London forces. So you have to understand that to say, oh, obviously, haloalkanes, aldehyde, ketones, and esters, they will have the highest strength in terms of strength of intermolecular force. It's a higher strength of intermolecular force. Why? Because obviously you are talking to 2 forces as compared to 1. So it's just like one person against 2 people. So obviously, you know, there will be a problem. So I hope you understand that to say alkenes, and alkynes, they have London forces. Haloalkanes, aldehyde, ketones, and esters, which I refer to as Higg, they have London forces and dipole-dipole forces. Now, our last two, AC, which is our alcohol and carboxylic acid. Remember, don't forget the format that I'm giving them to you. I'm saying AAA, then I said Higg, then I'm saying AC. So you must be able to check that it's okay. AAA, they have London forces. Higg, they have London forces and dipole. Now, when you go to alcohols, for example, they have and carboxylic acid, their force is called hydrogen bond. So they have three. This one, they will have London, dipole, and lastly, they will have hydrogen bond. So they have all the three hydrogen bonds. So now, obviously, these are the strongest intermolecular forces compared to the other two. Now, when we are dealing with these type of questions, if we are asking you the difference in strength of alkanes, for example, and haloalkanes, you will refer to the forces that brings about the difference between them. For example, a haloalkane, you will say they have dipole, while alkanes have London force. So already you are saying to us that if they have dipole, we will know that they have London force. I hope that will help you when we do the questions. So I'm saying to you now, description of each force. We're saying for hydrocarbons is London force. For haloalkanes, aldehyde, ketones, and esters, we're saying the forces are dipole forces. So you have to know that this is the force that differentiate them amongst each other. So that's why we refer to that. So you will see when I talk about forces found in alkanes, alkynes, I will refer to London forces. When I refer to haloalkanes, aldehyde, ketones, and esters, I will refer to dipole. Not to say that there is no London forces, but this is the force that differentiate them from London forces. So when I talk about alcohol and carboxylic acids, I will refer to hydrogen bonds. So the hydrogen bonds, they are the ones that makes them much strong. So you have to understand that. So we are saying the strength of intermolecular force. London forces are the weakest intermolecular force. They are low. But when you go to the second for haloalkanes, aldehyde, ketones, and esters, their forces, which is the dipole, they are stronger than London forces. So dipole are stronger than London forces. Don't forget, they are weaker compared to the hydrogen bonds. So they are not stronger than hydrogen bonds. They are only stronger than London forces. Then we'll go to our last forces, which is the hydrogen bonds. They are the strongest intermolecular force of all the forces. So we're saying we have three that we will be concentrating on for this lesson and for technical science: London forces, dipole forces, and hydrogen bonds. And we're saying AAA, which is our alkanes, and alkynes. We're saying they have London force. We're saying Higg, which is our haloalkanes, aldehyde, ketones, and esters. They have dipole, and alcohols and carboxylic acid, they have hydrogen bonds, as that slide indicate. Now, we are as well saying now in terms of the strength, you can see we've grouped them in terms of strength. To say AAA, the weakest, followed by Higg, which is now stronger. I'm just using this for you not to forget the 9 homologous series all the time, but you can't be writing AAA in the exam. Obviously, you will refer to their full names, which is alkanes, alkenes, and alkynes. We're saying they have London forces and they are weaker intermolecular forces. And now, remember what I said. Depending on the strength of the intermolecular forces, it's going to determine how much energy. Remember I said for us to overcome the intermolecular forces, what we need is energy. So we are always going to refer to the energy required to overcome the intermolecular force. So obviously with London forces, because are the weakest, least amount of energy will be required to overcome the intermolecular force. And when you look now in terms of haloalkanes, aldehyde, ketones, and esters, you will see that more energy is required than with London forces, but less energy compared with the hydrogen bond. And then for our hydrogen bonds, we're saying the most amount of energy will be required. Don't forget, always when we talk about energy, you must say is energy required to overcome the intermolecular force. So when you say less amount of energy is required to overcome the intermolecular forces, we're saying that is for hydrocarbons. But when you go to alkynes, aldehyde, and ketones and esters, we're saying more energy is required than the London forces, but less compared to the hydrogen bonds. But with the hydrogen bond, the most amount of energy will be required to overcome the intermolecular force. So now we are saying here, because remember we did the functional group. We said the functional group, you will remember, for an alcohol, we said you'll see it by the OH there, the hydroxyl group. So that OH, that hydroxyl group, is a site for hydrogen bond. So we're saying it has one side. But if we look at carboxylic acid, we said it's a C double bond O with an OH. So you can see the side of the OH, the side of the oxygen are two sides. So you see, alcohol, they have only one oxygen. So we're saying they have one side, this side where they have the OH is our one side of what? Of hydrogen bond. But when it comes to carboxylic acid, because of that is one side and that is another side. So we say it has two sides. So when you have an alcohol and a carboxylic acid, you have to know that the strongest will be a carboxylic acid because it has two sides. It's able to form two intermolecular forces there, our hydrogen bonds. So because of the two oxygens that it has. So all the time, know that for alcohols, we're saying it's one side of hydrogen bond, carboxylic acid, two sides of hydrogen bond. I hope I was able to explain this well. In the remember, I said if you have any question, 060-667-5044. So we'll be able to respond to your questions. Hoping that we are moving together. Now look at this one. London forces. You see, now remember I said London forces is the weakest. The London force is a weak intermolecular force between non-polar molecules. Look, a hydrogen and a hydrogen forming bond between them. So obviously, the strength of the intermolecular force won't be that strong because of that. I seek to indicate to you that we are talking about intermolecular forces, which is this force here between the molecules, not interatomic force or the bond. These bonds, we talk about them in question 4. When we break them, we do that. Here, we refer to intermolecular force. We don't break the intermolecular force. We overcome. What do we need to overcome them? We need energy. And I said to you, energy to overcome London forces, because at the weakest, will be least in amount of energy. So least amount of energy. So if you can check in our strategy towards doing the questions, because we're going to do the questions, I'm saying the first thing that you must look at is I said to you, if chain mob. So all the time you check, okay, what is the type of intermolecular force? You can see what the I is the intermolecular force. So what is the type of intermolecular force? You said, oh, this one is London force. So that is the first thing you will do. When you get a structure, identify its intermolecular force, and then we are able to move forward. So you see that is the London force, is between those hydrogens there. Hence we're saying is the weakest. Is the weakest. If we move now to the second one, which is our dipole forces. Our dipole forces now is the intermolecular forces found between polar molecules. Molecules in which there is an uneven distribution of charge, so that the molecule has a positive and a negative side. Remember, oxygen is more electronegative. So this is partially negative, and the carbon there is partially positive. So the same with this, partially negative and partially positive. Now, this, it has two poles. Remember, di means two. That's why we're saying, oh, this is a dipole and another dipole. Then the force between them, this force here, between them, we call it dipole forces, because it's between that, which is something that we don't have with the hydrogens, because you will know that they are not partially positive and negative on their own. We have to induce that so that there is a bond between them. So this bond is because of that partially positive and negative. You know, negative and positive, they attract one another. That's why it's stronger than the London forces. London forces is hydrogen and hydrogen, and then you know that we induce that attraction that happens between hydrogen and hydrogen. But this one's is a negative and a positive. They attract one another. Then it is stronger. You can see it is stronger than the London force. This is the dipole. It is stronger than the London force. So I hope you understand now why dipole are stronger than the London force. I think we are moving together. Now let's go to hydrogen bond, the strongest of our intermolecular forces. Remember we said there are 3 intermolecular forces we're going to focus on. Now we are on hydrogen bond. I told you that they are found in AC, which is the alcohol and the carboxylic acid. So what are we saying? We're saying in alcohols, we have that one OH there that we're having, and that will serve as a site for hydrogen bond. Hence we're saying one site. You see this hydrogen is forming with another oxygen there. Then that is the hydrogen bond. So you know it's hydrogen of one molecule and the oxygen of another molecule. So hence it's an intermolecular force. But this force is between these molecules. But we're referring to it as hydrogen bond. And then look at carboxylic acid as well. You will see that carboxylic acid has 2 sides because of the 2 oxygen, as I was indicating. So each oxygen serves as a site for the oxygen and the hydrogen, the OH there. They will serve as a site for hydrogen bond. So you are able to see, okay, we have 1 and 2. So we have 2 sides of hydrogen hydrogen bond. That's why alcohols are stronger than the other homologous series, but weaker compared to the carboxylic acid. So the main thing, what we need from you, will give you alkenes and alkynes. You have to know the type of intermolecular force. We said is London. We'll give you haloalkanes, aldehyde, ketones, and esters. And then we want to know from you that they all have dipole. And dipole are stronger intermolecular force than London forces. And then when we give you alcohols and carboxylic acid, you will remember, as we are here, we are saying, don't forget, all of them, they have hydrogen bond. You must write it in full. You can't write H bond. You write hydrogen bond. So they have hydrogen bond, but don't forget, we are saying for alcohol is one side. Alcohol is one side of hydrogen bond, while for carboxylic acid is 2 sides, as I've indicated on the slide there, to say one side for alcohol and 2 sides. So of all the 9 homologous series, the strongest intermolecular force will be carboxylic acid. Remember, if it's the strongest intermolecular force, it means that too much will need more energy to overcome the intermolecular force. Remember, we have 2 hydrogen bond sites here. Obviously, we're going to need more energy to overcome intermolecular forces in what? In carboxylic acid compared to alcohols, because alcohol, they have only 1 hydrogen bond, while the carboxylic acid, they have 2 sides of hydrogen bond. I hope you will understand and be able to answer questions, because now I can see questions are coming. We're going to enjoy, which is the main thing why you are here. You are able, after this, we want you to be able to see a question paper and be able to answer all the questions that are relevant to ourselves. Now, look at that. Try to indicate in that comparison of the strength of intermolecular force. I've already told you this, that London forces are the weakest, followed by the dipole, and our highest in terms of the 3 that we are comparing is the hydrogen bond. Now, what are the factors that affect the strength of intermolecular force? Now, the strength of intermolecular force, whether it will be strong, weak, strong, or strongest, it will depend on these factors. So we're saying, you will look, remember I said if chain mob, I was referring to that. It will depend on that. If chain mob, don't forget, I'm saying it will depend on the intermolecular force, on the functional group, on the chain length, on the molecular mass, and the branch. So we're going to look at that to say if the chain length is longer, so the longer the chain length, the stronger the London forces, or the shorter the chain, the weaker the London forces. So you can see that as the chain length increases, you are having more of the London forces that are increasing, because you are having more hydrogens with those carbons that are increasing with the structure. So as the chain length increases, we are saying that the strength of intermolecular forces increases. So you can see it's directly proportional, but you don't use that. This is paper 2. So you will say when the chain length increases, the strength of intermolecular force increases. It's a mark. When the chain length becomes shorter or decreases, the weaker the London forces that we will have. Now, let's go to branch. You see with chain length is simple because when the chain length increases, the strength of intermolecular force increases, which means the amount of energy required to overcome the intermolecular forces will increase. So now let's go to branch now. When the more the branch, when the branches increases, the structure becomes weaker. The intermolecular forces, and we are referring here to what on the same homologous series. You will see, let's say you are having a structure of butane and the structure of 2-methyl propane. Yes, those two. You can see they have the same number of carbons and hydrogens. They have the same molecular mass. But butane is unbranched. 2-methyl propane is branched. So the one that is branched, the strength of intermolecular force will decrease. So all the time when you have branches, you must start to look to say, as the number of branches increases, the strength of intermolecular force decreases. And when the strength of intermolecular force decreases, less amount of energy required. You see, the order is always that. You always have to talk about the strength of intermolecular force, which will determine how much energy will be required to overcome that intermolecular force. Now, the number of functional groups as well. You remember we said our hydrogen bonds will be stronger than the dipole-dipole, which is stronger than the London forces. So as we indicated on different homologous series. So I hope that as well increases. So I explained the chain to say as the chain increases, the strength of intermolecular force increases. As the strength of the intermolecular force increases, the energy required to overcome the intermolecular forces will be high as well, will increase as well. The same with molecular mass. Remember, if the chain is increasing, it comes that the molecular mass will increase. And as the molecular mass increases, the strength of intermolecular force will increase. As the strength of intermolecular force increases, the amount of energy required to overcome the intermolecular force will increase. So always in that order, So you will identify the force, what type of force, is it stronger, is it weaker? Then you are talking about the strength. After the strength, then you talk about the energy. So I hope that helps you. You will see when you start with the questions so that you are able to answer them. So that was our strength of intermolecular forces. Let's look now. We said we are doing melting point, boiling point, viscosity, and vapor pressure. So you have to know that if the strength of intermolecular force increases, it comes that the boiling point will increase. But if the strength of intermolecular force decreases, even the boiling point will decrease. The same with melting point. When the strength of intermolecular force increases, the melting point will increase. When the strength decreases, the melting point will decrease. Even for viscosity, when the strength of intermolecular force increases, then viscosity will increase. When it decreases, the viscosity will decrease. So all the first three physical properties that we are doing, they increase with increase in the strength of intermolecular force. So they increase with increase in the strength of intermolecular force. So you have to know at all times that these first three, when the strength, so what matters is for you to know the strength, because it will tell you how the boiling point will behave, because the boiling point, melting point, and viscosity, they behave the same way as the strength. If the strength increases, the boiling point increases. If the strength decreases, the boiling point will decrease. So I hope you understand that. But when it comes to vapor pressure, is another way around. So if the strength increases and the boiling point increases, the vapor pressure decreases. So what am I saying? I'm saying vapor pressure decrease with increase in the strength. So when the strength of intermolecular force increase, vapor pressure decrease. So be careful all the time with vapor pressure. It's like that. One arrow up, one arrow down. So when the strength increase, The strength of intermolecular force, when it increases, the vapor pressure will decrease. So remember that all the time. So you just have to know that the first three, all of them, they increase with the increase in the strength of intermolecular force. They decrease with the decrease in the strength of the intermolecular force. Now, vapor pressure, another way around. With the vapor pressure, it's now when the strength increases, the vapor pressure will decrease. I hope we're moving together. Now, I'm going to give you this nice example. Immediately after examples, we're going to do activities. I hope you will enjoy, because we're going to utilize all our strategies so that you are able to answer any question. In terms of question 3, you must be able to do very well here. Now, number 1, it says boiling and melting point of organic compounds increase with increase in strength of intermolecular force. As I indicated, even viscosity, I indicated that it increases with the strength of the intermolecular force. So if the strength increases, then more energy is needed to overcome the intermolecular force. Now, let's look at this one. We're saying the effect of functional group. Remember, if the functional group changes, you will expect that there might be change in terms of the type of intermolecular force. But that statement is not entirely correct. I want you to understand it this way. Let's say we are having an alkane and alkyne. You will know that they don't have the same functional group, but they have the same intermolecular force. So as we are changing the intermolecular the homologous series, the type of forces is remaining London force. So it depends that we have different homologous series. For example, our haloalkanes, aldehyde, ketones, and esters, all of them, they have dipole, but they are different functional groups. So sometimes you look at that as well to say what type of homologous series and what type of intermolecular force. Let's look at this one. We're given a pentane. You know, a pentane is an alkane, and you know, remember, we said AAA, alkanes, alkenes, and alkynes, they have London forces. London forces, we said, are the weakest. Intermolecular forces, we said less amount of energy is required. Remember, less amount of what? Of energy is required to do what? To overcome the intermolecular force. To overcome intermolecular force. So you have to have that in mind. So when you see pentane, you must, the first thing that comes to your mind is we're using here what you call ice. Ice. So when you look at ice, we're simply saying now, because of that ice, we're saying identify the type of intermolecular force. What intermolecular force do we find in pentane? Oh, we have London force because it's an alkane. What type of force do we find in pentanone? Or it's an alcohol. So we said it has one side of hydrogen bond. You don't have to mention one side. The time when you have to mention the sites of hydrogen bond, site of hydrogen bond, is when you're comparing alcohol and carboxylic acid. But alcohol and others, or carboxylic acid and others, you will just refer to hydrogen bond. So you will say London force for pentane and hydrogen bond for pentanone. So this is hydrogen bond, which is the I, the type of intermolecular force. Then you must compare the strength. Number 2. So for all the questions you are finding, you are following that. You say, now I'm going to compare the strength of the intermolecular force. So you can choose to talk about London or talk about hydrogen bond. To say, okay, if you are going to talk about London forces, you'll say, okay, the type of intermolecular forces in pentane is London forces. In pentanone is hydrogen bond. Then that is your first bullet, because we want you to answer in bullet form. We don't want you to be writing too much paragraph, because sometimes you lose information, you contradict yourself in long statements. So be in point form, bullet form. First bullet, you are saying the type of intermolecular force is for pentane is London force, for pentanone is hydrogen bond. That is the first bullet that we are talking about, the type of intermolecular force. The second bullet, you're going to tell us about the strength. Which one is weaker? You're comparing, remember, which one is weaker, which one is stronger. So you can simply say, okay, London forces found in pentane are the weakest intermolecular forces as compared to hydrogen bond found in pentan 1 all. You see, you are comparing the two. The other one is weaker. So immediately when you say is weaker, weaker than what? So London force is weaker than hydrogen bond found in pentan 1 all. That is the second bullet. You are comparing them. The third bullet, our third bullet, we are going to say, okay, remember, when you know the strength, you know the energy. If you in this case, you selected to talk about the London force, you said it's the weakest or is weaker because you're comparing. You said it's weaker, is weaker than the hydrogen bond in pentan 1 all. You said its name is London force for pentane. You're talking about pentane here. You said it has London force as compared to pentan 1 all, that is a hydrogen bond, and then you're saying it's a weaker, the strength is weaker compared to that of the pentan 1 all, and then you are saying how much energy. So you'll be saying, say, because it's weaker, it means less energy is required to overcome the intermolecular force. So that is your strategy. So always go with that eyes. Identify the type of intermolecular force, compare the strength of intermolecular force, and then the energy required to say how much energy do we need. Because if you are saying I'm weak, you are simply saying I won't need much energy to overcome you. So that's what you're saying. So all the time, talk about the strength first before you talk about the amount of energy. So to say, is he strong? Is this weak or strong? Is this intermolecular force stronger or weaker? If it's stronger, then you are saying more energy will be required to overcome the intermolecular force. So I'm hoping that we are moving together. I'm quickly going to give you a short break. When we come back from that break, we'll be doing activities now. You'll be enjoying yourself. We'll start with multiple choice. When we come back, then we go to structured questions. So I'm hoping that we are moving together and you are enjoying the lesson. So we will meet immediately after the short break. Then we'll start with multiple choice. We won't do too many. Maybe we'll do 5 questions, multiple choice. Then we do structured questions. So I'm hoping to see you immediately after 5 minutes. Thank you very much. You can drink water for now. Welcome back. Welcome back to our technical science lesson. It's still myself, Mashid Mamburu. This lesson have been brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and is broadcast by Pagama Research and Development. Remember, our WhatsApp is still 060-667-5044. You can ask any questions there. Now we are going to be dealing now with multiple choice questions. I'm hoping you will enjoy this. Remember, with multiple choice, we're saying you are given 4 options. And what you have to do is to get rid of 2 disruptors at least. Because out of 4, you are having 25%, 1/4 chances of getting the answer correct. So we're saying increase your chances by eliminating what we refer to as disruptors. A disruptor is something that is not an answer, it's just there to disrupt you. So always don't be in a hurry. Remember, you have 2 marks for each multiple choice question. So it's very much important that you spend that 2 minutes there to be able to get that 2 marks. I hope that will help us. We have 20 marks that we get from this kind of question, so we are expecting you to collect that in terms of our papers. Now, 1.1, it says the temperature at which vapor pressure of a substance is equal to the atmospheric pressure. Remember, for you to get rid of disruptors, you'll say vapor pressure. Oh, you know, vapor pressure, our substance must have reached the boiling point. We must be nearing the boiling point. It can't be melting, and then we're talking about vapor pressure. So it's very much important that, you know that our vapor pressure now, we can say freezing is out. Melting point is out. So those 2 are real disruptors. So you know, equals to is equal. Oh, equal, you know, is boiling point. You said the vapor pressure inside of the liquid is equals to the atmospheric pressure. Obviously, the atmospheric pressure is the pressure in the atmosphere. So you know that our answer will be number D. So that's how you go about answering that question. Let's look at 1.2. It says, which one of the following compounds has the highest boiling point? So you know, you look, when you get a question like this, it's important to check first. Remember whether what is changing here. What is changing? What is changing is what we refer to as our independent variable. So if you look here, what is changing? We had 2 carbons in the first one, 3 carbons and 8 hydrogens in the second one, option B. Option C, we have 4 carbons. Option D, you have 5. So you can see that what is increasing is the chain length. Then you simply go to our previous notes to say, we said as the chain length increases, the strength of intermolecular force increases. And as the strength of intermolecular force increases, more energy will be required to overcome the intermolecular forces, which means boiling point. We're talking about boiling point. So we're saying which one will have the highest boiling point? Obviously, is the one with the longest chain length. So here we're looking at the chain length. So you're able to choose to say chain length, then you are rich. You are 4 marks richer. Then we're able to move to our next question to say, let's look at other multiple choice questions. Now, this one is saying study the vapor pressure. Remember, with vapor pressure, we said as the strength, that's the thing that you must do immediately. To say with vapor pressure, as the strength increases, vapor pressure decreases. So strength, as the strength increases, vapor pressure decreases. So you don't have to forget that. Let's look at this question. It says study the vapor pressure versus temperature graphs for a secondary and tertiary alcohol. So remember, alcohols, we have secondary and tertiary. Remember, tertiary, we said, let me talk to the secondary. We said the carbon that is bonded to the OH is bonded to, so this will be tertiary. The carbon that is bonded to the OH is bonded to 3 other carbons. So for secondary, the carbon that is bonded to the OH, I can just put it here. The carbon that is bonded to the hydroxyl group is bonded to 2 other carbons. So you can see this carbon that is bonded to the OH is bonded to 2 other carbons. Then this carbon that is bonded to the OH, the hydroxyl group, is bonded to 3 other carbons. So we know that, okay, this one is a tertiary one. This one is a secondary one. You know, for primary, the carbon will be, the OH will be in carbon number 1, so that the carbon that is bonded to the hydroxyl group will be bonded to one other carbon. So the first thing is for you to understand what is primary, what is secondary, and what is tertiary alcohol. So once you are there, you're saying, okay, now let's go and look at the strength to say what happened to the strength of intermolecular force when you move from primary, secondary, and tertiary. You will see that as the primary, secondary, because if you look at this a tertiary structure, it's as good as branched. You can see that there is a branch there. There is a C there. That is a branch, but this one is unbranched. So you will remember that when we have a branch and unbranched, then you know that as the number of branches increases, the strength decreases. So you are expecting that the tertiary alcohol will have the lower strength, will be lower strength of intermolecular force. Lower strength of intermolecular force. While for primary, it will be, the strength will be higher. The strength will be higher, which means the strength will be higher for that one. So now, if the strength of the intermolecular force is lower, the vapor pressure will be higher. Remember what I said about vapor pressure, to say if the strength is low, the vapor pressure is high. But if the strength is high, the vapor pressure is low. Remember with the others, we said as the strength increases, even they increase. Melting point, boiling point, and viscosity. We said they increase with the increase in the strength of intermolecular force. However, when you talk about branches, in this case, I think branches it explained this nicely. But you have to know that as we move from primary to secondary to tertiary alcohol, the strength of intermolecular force will decrease. The strength of intermolecular force will decrease. So you see there. So we're saying this is the lowest, weaker intermolecular force as compared to this one, which doesn't have a branch. So if the strength is lowest, vapor pressure is highest. Now let's look at that question. It's saying which one of the following is the boiling point of the tertiary alcohol. Now we were talking about the vapor pressure. Remember vapor pressure? We said what is the boiling point is when the atmospheric vapor pressure is equals to atmospheric pressure. When the vapor pressure is equals to atmospheric pressure. Now, the most important thing is to check, okay, to say, oh, the question is saying which one of the following is for tertiary. Tertiary, it has the lowest strength of intermolecular force. We said, remember with boiling point, we said they are directly proportional, or as the strength increases, let me write this side. So for boiling point, we're saying as the strength increases, strength of intermolecular force increases, we're saying the boiling point will increase. So you can see this one is the weakest intermolecular force compared to this one. So because this one is weaker, our tertiary, because the question is about tertiary alcohol, is weaker, which means its boiling point would be lower because it has a lower strength, which means lower boiling point. So you can see between these two graphs, they say atmospheric pressure is 100 kilopascal. So you just go to 100 there. You can go there, 100. You go, this is our 100. Can you see that? Then you said the secondary will have the highest strength, which means for secondary, it will have a higher boiling point, which is here at 100. But for tertiary, because it has the strength is lowest, so it will be there. So you're able to say, okay, I can see my answer now, because at 100 kilopascal, the temperature is 80 degrees Celsius. So you are able to go and choose your option, which is number A. Maybe because this is a graph, let me explain it for the last time so that I don't lose you. The first thing you look for is the strength, to say what is the difference in the strength of a secondary and tertiary. I'm saying in terms of the strength is lower. Strength for tertiary is lower. Strength for secondary is higher. If strength is lower, boiling point is lower. So you have to get it from there. If strength is lower, even the boiling point would be lower, because boiling point decreases with decreasing strength of intermolecular force. So you are able to see that, okay, the one that is having a lower boiling point here in this case is because of the strength, it will have a lower boiling point. It's our tertiary alcohol, which is our option A. I hope you will look at that question once more and do it, because it's from some of the previous question papers. So just check previous question papers, you'll be able to get it and be able to practice such questions. I hope you got that. Now, the last two multiple choice that we're having, we're saying the vapor pressure of ethanol is an alcohol, is lower than the vapor pressure of ethane, lower than. Because ethane has, remember what we said. We said you must know ethane is an alkane, so it has London force. It has London force. London force is weaker. If London force is weaker, and then if London force is weaker, then the strength is weaker, then the energy needed would be lower energy needed, not more energy needed. It would be lower energy that is needed. So you have to know that, for alkanes is that it must have, you're expecting alkane not to, remember I said we are given 4 options. So of the 4 options, we are saying 2 are disruptors. So ethane, it cannot have a higher boiling point than ethanol. Ethane it must have a lower boiling point. So anything that says ethane has higher boiling point, it cannot be correct. So it cannot be higher. Why? Because the strength of intermolecular force for London force is the weakest. So it has weakest intermolecular force. So it means even its boiling point will be lower. So even this one is saying its boiling point is higher of ethane, cannot be higher. It doesn't have a higher boiling point. Ethane doesn't have a higher boiling point and it's not stronger. So we're left with 2 options, which is B and D. So that's what we're saying. Get rid of the 2 disruptors that might bring problems for you. Now you have 2. To say ethane has a lower boiling point. All of these points, you're agreeing with them. Ethane has a lower boiling point. And weaker, does ethane has weaker or stronger? Obviously. Compared to ethanol, ethane has weaker intermolecular force. So you're able to choose to say, these 2, they qualify here, but this one, ethane is not stronger, is weaker. So this one is the correct answer, which is 2 marks now. So you're able to get to 2. So when you leave your exam, you must be able to know that I've collected all my multiple choice questions, because those questions will help you to get the results that you want. Let's look at the last question. It says, in which one of the options below are the intermolecular forces arranged from the weakest to the strongest? So always follow that to say weakest to strongest. So if you still remember, AAA, London force, the weakest. Hague, dipole, stronger than London force. AC, alcohol and carboxylic acid, hydrogen bond, the strongest. So obviously it must be from London, because they said from weakest. Be careful of this, because we can change the question in the exam and say from strongest to weakest. Then you have to write them the other way around. So from weakest is London, followed by dipole, followed by hydrogen bond. So you see that your answer must be London. So this doesn't start with London, so it's wrong. This doesn't start with London, it's wrong. This doesn't start with London, it's because the weakest is London. So the option D is your option. Hoping you are enjoying this and you will practice more of multiple choice questions. Now we move to structured questions, because I hope now you are ready for these types of questions to say, I can do this. Let's look at this activity taken from a previous question paper, 2020. We're given the table shown below. Below shows organic molecules with different molar masses. So you were given different molar masses and vapor pressure. It's very much important to know. We said the first 3, which is boiling point, melting point, boiling point, and viscosity. In that order, I said to you, these 3, when the strength of intermolecular force increases, they increase as well. So Viscosity will increase with strength in the intermolecular force. Boiling point will increase with increase in the strength of intermolecular force, as well as melting point. It will increase with increase in the strength of intermolecular force. However, when it comes to vapor pressure, is when the strength increases, the vapor pressure decreases. So you must be careful of that. Let's look at this one. We're given propan, one propanol there. You know, one propanol, how many carbons in prop? It's 3 carbons. So it's a 3 carbon alcohol. And then one butanol is a 4 carbons alcohol. One pentanol is a 5 carbon alcohol. So you have to know that, okay, what is changing here is the chain length. What is changing here is the molar mass. So how is the molar mass increasing? Molar mass is increasing from 60 to 74, 88. So you have to know that as the molar mass is increasing, which is your independent variable, your dependent is what you are measuring. So we're measuring vapor pressure. So this is our dependent variable all the time. Sometimes we're asking you to identify the dependent variable and the independent variable. So know at all times that your independent is that which is changing during these questions, and the dependent variable is the one that you are measuring during the experiment. So we're measuring vapor pressure, we're changing the molar mass. Now, if you look at this, you will be able to see that, okay, before you have to analyze the table. Don't be in a hurry to answer questions. Understand what is happening on the table first. That's why I said the first thing we looked at the chain length. So this is 3 carbons, 4 carbons, 5 carbons. That is the chain length. You can see the chain length is increasing, and as the chain length increases, the molar mass increases. So as the chain length increases, the strength of the intermolecular force increases. So you can see as we go down these groups, the strength is increasing. But let's look at the vapor pressure. As the strength increases, the vapor pressure is decreasing. So you can see the vapor pressure increase, decrease with increase in the strength. So when the strength increase, the vapor pressure decrease. So you can see here, the strength is increasing as the molar mass increases. The strength is increasing as the chain length increases, but the vapor pressure decreases. So always, you know, with vapor pressure, when the strength increases, vapor pressure decreases. I hope I've emphasized that many times so you understand that. So we're simply saying now, when you go to questions, already you can see what we're going to ask you, and it becomes easier for you because we're saying define the term vapor pressure. Remember, when it comes to definitions, we want two or nothing. We don't want you to write a statement that is not correct. So use the exam guideline to get all these definitions are correct. Remember, with the vapor pressure, we said is the pressure exerted by vapor at equilibrium with its liquid in a closed system. Don't forget to say that. So we're saying it's a pressure exerted by vapor at equilibrium with its liquid in a closed system. So you have to know that it is in a closed system because we said already the water, I mean the substance has boiled. So when we are around there is high temperature. So we're expecting that it must be in a closed system so that nothing escapes. So don't forget definition of vapor pressure. Just look at the name itself. You say it's a pressure exerted by vapor at equilibrium with its liquid in a closed system. So don't forget that closed system is very much important. But use the table above to answer questions that follow. Now, if you look at this one, you're going to say, okay, describe the trend in vapor pressure of compounds above. The trends. So the trends is you can see that as the molar mass, the first thing you will see is that as the molar mass increases from one propanol to one pentanol, the molar mass increases. As the molar mass increases, the strength of intermolecular force increases. The vapor pressure decreases. So that is what you can see when you look on the table. You can see as the molar mass increases from 60 to 74 to 88, as it increases the molar mass, what happens to the vapor pressure? It decreases from 21 to 2.2. So that is the trend. So the trend is directly for you there from the table. You're just analyzing that information. Now, question 3.2.2, it says, explain the answer to question 3.2.1. Refer to the chain length or molar mass, strength of intermolecular force, and energy. Remember the I's that I talked to you about. So it's very much important to say when you are studying, you will always look for the independent variable to say which one is changing and how is it changing. So we said what is changing is the chain length from 3 carbon, 4 carbons, 5 carbon. So the chain length is changing. So the first thing you'll talk about is the chain length. Or you can talk, most of the time I will advise you to always use the information that is given on the table. Like in this case, the molar mass is given on the table, unlike the chain length, because you have to analyze the propanol is 3 carbons, butanol is 4 carbons, but the 60, 74, and 88 are given. So rather, answer the question using the information that we are given on the table to say, as the molar mass increases, so that will be your answer, as the molar mass increases, as the molar mass increases, the vapor pressure decreases. That's what we said in statement number 2. Now we are saying the chain length. What is happening to the chain length? The chain length or the molar mass increases. As the molar mass increases, what happens to the strength of the intermolecular force? Chain length increases, the strength increases. The strength of the intermolecular force increases, and the energy required will increase. Obviously, as the strength increases, the energy required increases. So we are saying here, you will say the first thing is chain length. Chain length, you said it increases. As it increases, you said the strength of intermolecular force. Don't write IMF in the exam. It's intermolecular force in full. The strength of intermolecular force increases. As the strength of intermolecular force increases, what happens to the energy? More energy is required. More energy is required. Remember I said more energy is required to overcome the intermolecular force. To overcome the intermolecular force. So always write it like that in bullet form. So you'll write those 3 bullet. Then you can conclude by saying, oh, therefore, when this happens, the vapor pressure will decrease, because when the strength increases, the vapor pressure decreases. So you are able to collect all your 3 marks there with no difficulty. And this question is all about that, you being able to identify the questions that we're having. Here is another question that is based on viscosity. It's a nice one. I thought it will be of good help to say, during an investigation to compare the viscosity of alkanes, learners used a stopwatch to measure the time it takes a fixed volume of each alkane to flow from a pipette as shown below. Remember, in simple ways, we are simply saying the resistance of a fluid to flow. How much does a fluid resist flowing? That is viscosity. But in terms of our exam guideline, you have to define it in this way to say, is the property of fluid to oppose relative motion, the property of fluid to oppose relative motion between 2 adjacent layers. So we have that definition. So you can see now we're having those alkanes there in the pipette, then they are flowing to that beaker. So we're going to look their resistance, how much they oppose that motion, how slower or how fast they move. So we're going to look at that for this particular question. Obviously, the first question say define the term viscosity. You only define according to exam guideline, which is the property of fluid to oppose relative motion between 2 adjacent layers. Property of fluid to oppose relative motion between 2 adjacent layers. So you get your 2 marks for the definition. Now, which alkanes A, B, or C has the highest viscosity? So it means if the strength of intermolecular force increases, obviously its viscosity will increase. Remember I said melting point, boiling point, and viscosity, they increase with increasing strength. So it means the one which is having more resistance to flow, it has a higher viscosity. So in this case, we can check the strength. You can see, look at number A there. is 2.2 dimethyl propane. So it means it's branched. It has two branches. 2-methyl butane, it has one branch. And then pentane, no branch. You can see. And remember what we said. As the number of branches increases, the strength of the intermolecular force decreases. So you can see that the one with the highest strength of intermolecular force is pentane. Pentane has the highest strength of intermolecular force, meaning more energy will be required to overcome this one, pentane. So you can see now that it is more viscous because pentane, it has taken 0.35 minutes as compared to 2-methyl butane that took just under 0.3 minutes there. And you have 2.2 dimethyl that is flowing very fast. It took 0.214. Remember, we're saying how long will it take from the pipette to the beaker? So it takes longer for pentane because it has a higher viscosity, which is our compound number. Remember, so that we don't get this one wrong and you are not confused. Which alkane A, B, C has the highest viscosity? So that one would be pentane because we're talking about viscosity. Then the question says, explain the answer to question 3.2. So I said to you, what is changing here is branch. So you will simply say pentane is unbranched. It has 0 branch as compared to the 2-methyl butane and 2.2 dimethyl propane that are branched. So if a compound is not branched, it means it has the highest strength of intermolecular force because it's unbranched. So it's unbranched, and by it being unbranched, it has the highest strength of intermolecular force compared to the other two. And if it has that, you see the max is 3. You will talk about that is it is unbranched, and because it's unbranched, the strength of its intermolecular force is the highest, and because of that, more energy will be required. Don't forget, to overcome will be required to overcome the intermolecular force. Now, 3.4. Which alkane A, B, or C has the highest vapor pressure? Remember, with vapor pressure, the strength must be lowest. So the lowest strength is 2.2 dimethyl propane because it has 2 branches there. So it's the lowest strength. If it's the lowest strength, it has the highest vapor pressure. So you know that for this one, A will have the highest vapor pressure. Why? Because the strength of the intermolecular force is the weakest for A. Why is it the weakest? Because it is more branched than others. I hope that clarifies it for yourself. Now, 3.5, compound A and B have lower boiling points than compound C. Write down the definition of boiling point. So this question is all about that. Boiling point. What is boiling point? Remember, boiling point, we said the vapor pressure is equals to the atmospheric pressure. Don't forget, you start with the temperature. Don't make that mistake that I referred to when I started the lesson. I said you don't say the point. You say the temperature at which the vapor pressure is equals to the atmospheric pressure. You write vapor pressure is equals to the atmospheric pressure in full. So I'm just simplifying it for you so that you don't forget at all times and you are able to collect as many marks as we can. Now, I think this will be our last question for the day. And I hope you have understood everything that we're doing and you are moving with me. Now, look at this one. It says define the term functional group. So when it says define the term functional group, you will be able to go back, analyze the table just fast. Analyze the table to say, okay, we're given CH4, or CH4 will be methane, this will be ethane, this will be propane, this will be 2 carbons, so that is our ethanol. In real sense, the question should have been like this. Remember, I said we don't want to be doing more of condensed structures. Rather, we focusing on our general formula, molecular formula, and structural formula. So this one, hence I'm writing it in names to say it is methane, it is ethane, it is propane, it is ethane. It's ethanol with the alcohol OH there. Now, if you look here, you can see as we move 1 carbon, 2 carbons, 3, as the chain length increases, you can see that the boiling point is increasing. Remember, a smaller negative is the biggest number in that order. So minus 164 is less than minus 42. So you can see that as the chain length increases, then we are having our boiling point increasing. With ethanol, boiling point is 78. So first question, 3.1, define the term functional group. Remember we said a functional group is an atom or group of atoms that determines the chemistry of an organic molecule. So it's an atom, group of atoms that determines the chemistry of an organic molecule. So write down the name of the functional group of alcohol. We call it hydroxyl group. Hydroxyl group. So you must know the name of all the functional groups that we have done, so that you are able, if we ask you to name the functional group, you are able to write the name of the functional group. We didn't say draw here, we say write its name. Okay, 3.3, the boiling points of compound A, B, C are compared. In what phase are these compounds at room temperature at 25 degrees Celsius? Remember, room temperature is 25 degrees Celsius. Choose from gases, liquids, or solids. There we are referring to compound A, B, C. If we look, the temperature is increasing. This one boils at minus 164. This one boils at minus 89. This one boils at minus 42. So all of them, 25 is very high temperature for them. They will all be in gases. Why? Because they've boiled at lower temperature. Remember, after boiling, you have vapor, then you have the gas. The liquid will be converted to the gas. So we are saying they will all be at gases because they boil at temperature lower than 25. I hope you get that question because it's one of the questions that is very popular in our question papers. Name the type of intermolecular force found in these compounds. All of them is alkanes. You know alkanes, they have London force. State and fully explain the trend in the boiling point from compound A to C. Already I've given you the highlight to say the chain length from 1 carbon, 2 carbons, 3 carbons. So you can see that the chain length is increasing. As the chain length increases, the strength of the intermolecular force increases. So that's how you're going to go about it. So the first thing, you will identify that the chain length is the one that is changing here. So always you start with that. What is changing? What is changing is the chain between A, B, C. What is changing is the chain length. So the chain length, as the chain length increases, the strength of intermolecular force increases. The strength of intermolecular force increases. Then as the strength of the intermolecular force increases, more energy is required. More energy is required to overcome the intermolecular forces. So I'm hoping and praying that all these that we talked about and the order that you are supposed to put. So the first thing, always when you start, you're looking for your independent variable to say, what is my independent variable? What is changing in this table? You say it is the chain length. So you know, you answer this question based on the chain length. To say, as the chain length increases, what happens? The strength of the intermolecular force increases. What happens when the strength of the intermolecular force increases? More energy is required to overcome the intermolecular force. So the order is of paramount importance. I'm hoping and praying that you have understood this chapter and you will do very well in terms of this question. Remember, it's question 3 in our papers. And it's one of the questions that our learners have not been doing very well. So I'm hoping that with this lesson, you will be able to go and revise and practice as many questions as possible. Remember what we said, eyes always get to know first what is the independent variable. What is is it the chain length? Is it the molecular mass? Is it the branch? We talked about all those 3. Is it the functional group or is it the intermolecular force? So what is changing? You always check that from the given information. What is changing? That is your independent variable. You start with it. If it is the intermolecular force, you will identify the type of intermolecular force. Then you tell us about the strength. You compare. The C is for comparing. You compare the strength of the intermolecular force, and then you compare the energy required to overcome the intermolecular force. So I hope we had a very nice sessions. You have understood. Until we meet again. Thank you very much.